Now it is my pleasure to introduce our morning keynote speaker. Gilman Louie is a partner at Alsop Louie Partners and the CEO of America's Frontier Fund, a nonprofit that invests in foundational technologies critical to U.S. national security. Mr. Louie has over 30 years of national security and investment experience. He served as an early CEO of In-Q-Tel, as an expert to the Defense Innovation Board, and as a commissioner on the National Security Commission on Artificial Intelligence. Listen to this. Mr. Louie is currently the chairman of the National Intelligence University, chairman of the Federation of American Scientists, a member of the President's Intelligence Advisory Board, and a member of the U.S. Department of State's Foreign Affairs Policy Board. I don't know how you had time to be here today, but we're glad that you are. Please welcome to the stage Gilman Louie.
Look, it's great to be here in St. Louis for a number of reasons. This is the geospatial capital of the world, and we should own it. And I think St. Louis has more to offer than just its technology. It really has to offer its talent and its wisdom. And in that context, I want to talk a little bit about generative AI, because that's on the minds of everybody. I don't know any college professor, any high school student who doesn't know ChatGPT, right? We now go to ChatGPT for everything. It's as if the search box never existed. And whether it's researchers, whether it's folks in government or individuals, we are having conversations with algorithms to inform potential possibilities, to interrogate, to go back and forth in a different kind of relationship with the machine than we've had in the past. Now, what's interesting is, for this current new generation, we think all of this is new, but the reality of ChatGPT goes way back to the early 60s when we had this little toy we call Eliza, which had exactly the same interface. It was this little block of code we wrote in this language called BASIC that mimicked a psychologist. And we interacted with it, and for about 5 minutes, it could fool you that it was a real person behind the curtain, but it really wasn't. This is a different world. And AI today is not your father's Oldsmobile of the past. And I want to walk through not only the impact, but how generative AI and its future derivatives will fundamentally change how we think about geospatial. It is not just about how it enhances geospatial, but actually fundamentally change it. And so my discussion is really about moving away from the old frameworks of geospatial intelligence to real geo-knowledge, right? This idea of geography and understanding geography fundamentally as it affects every one of our decisions today. Now imagine 20 years ago when we were talking about the Rand McNally, trying to drive with this big book in your face as you're kind of going down the freeway, trying to figure out where you are. And now how we've integrated all of that in everything. It's in our pockets, right? It's in our cell phones. The things that were not mentioned is I'm on the board of Maxar, which provides a lot of the imagery, but I'm also on the board of Niantic, which does Pokemon Go, right? To imagine that we could generate billions of dollars in revenues by having digital characters running around in a physical world that people are happy to give me their money for every minute of the day. So it's a whole new world that's in front of us. So what am I talking about in geo-knowledge? It's not about maps, and it's not about imagery. It's about taking any point in space or any region in space, this X, Y, and Z point that we can admire and project it from over a period of time, from the past to the present and to its potential into the future. And knowing everything about this point that's relevant to why I'm interested in it at this moment. it has context, it has knowledge, it has information, it has truth. And being able to interrogate that point or that space is why we're all here. Now, trillions of dollars have been made in the industry over information technologies built around the search box. We have yet to organize the world's data geospatially. There's no place you can go on the internet today where you can start. You might go to Google Earth, you might go to Esri, right? All different peaks at what the world may be. But to be able to say, give me all the information about this point space and this point in time that I'm interested in the past or in the future, give me the answer. It doesn't exist. So that's the great opportunity. It's a great opportunity for our warfighters. It's a great opportunity for our consumers. It's a great opportunity for knowledge and science and discovery. And if we can do that, we can project out into the future. Now, I just want to give you a quick review of kind of AI by the numbers. And I bring this up because specifically large language models are greatly misunderstood. Large language models are the foundation of generative AI. First thing you should know, it's big business. Why is that important? Because when there's $2 trillion riding on it, investors, entrepreneurs, talent, and industry will go rushing down to solve real problems. So for all of you who have parents who say, why don't you get a real job? You can tell them that that's what you're doing. You're going to be defining a new industry that fundamentally doesn't really exist today. Now let's talk about generative AI and some greatly misunderstood numbers and principles. Principle number one, historically around artificial intelligence, was that data wins. Right? We all talked about data repository, having exquisite data, making sure our data warehouses are clean, that we do ETL transformations, right? It's all about the data. The Chinese bet on data. If you look at all the things that the Chinese are doing, it's all about the data. And what did the ChatGPT team do? They changed it around. They said it wasn't about data, it was about compute. And whoever has the most compute is going to win the day. That's why when you hear things from our Commerce Department about restrictions of certain kinds of microprocessors to be shipped out overseas, it's because the fundamental understanding is that compute gives you knowledge. So the idea of generative computing is not about specialized data sets. Yes, they do help. But it's about integrating and digesting all the world's information to build a model that costs, by the way, billions of dollars to build. These are not cheap. This is not something you do in your mom's kitchen. To build a large language model that's relevant, Google estimates it's going to take for the next iteration $5 to $10 billion. So it's not cheap. The other thing is, once you compute the large language model to actually run the model, we'll be able to run it probably on the iPhone 16. In other words, one generation away, I can put the entire large language model of GPT-4 actually in my pocket with no connectivity. From a warfighter point of view, from a consumer point of view, from an intelligence point of view, that's a game changer. Okay. Look, here's the fundamental impact that we're going to have and see that takes place. Yes, this list is really important. You should all copy it. You should all write it down, right? We can use generative AI to improve imagery. We can do super high resolution enhancements. We can take it and fill in the data blanks where data is missing. We can use generative AI, right, to perfect some of our narrow AI models. We can use generative AI to do scenario generation. But the most powerful thing about generative AI, right, is its flaws. Now, why did I say this? Anybody who's used generative AI knows it has prone to this thing we call hallucinating, right? So my favorite is I put my name in. And it actually comes back with a set of results. And I said, ask ChatGPT, where are all the awards I have won over the years? And it gives me a list, and it gets about 90% of them right, and there's 10% I have never won. But it says I've won them. So I take that list. When I'm wearing my White House badge, I go to the White House, and I said, you owe me 10 new awards. Right? Because this is what ChatGPT says. That hallucination is fundamentally the computer imagining, being creative. It's just like my 18-year-old daughter. Sometimes she doesn't distinguish what she's thinking from reality. She blends those two things together. It's kind of like ChatGPT. But we can leverage that, because those missing points could be the solution to any particular problem. So there's a whole field of research right now thinking through how do we solve and make it not hallucinate. What we should be doing is taking those hallucinations as solution potential sets for solving classes of problems to fill in data points that are currently missing. The other thing that generative AI does is it allows us to compress time, right? Because what we're doing with the machine is temporarily we are collapsing the past, the current, and the future into a single state. And I'll explain why this is really critical for what we got to do in the world that we have going forward. Now, here's some things that are different. As I said earlier, it's not about the data. And by the way, generative AI is not the solution for everything. Here's a couple observations that Google and the OpenAI team has noted, and we should be very aware of this. While a narrow AI model can outperform a generative AI model at a moment in time, within one turn of the crank, to the next generation of runs on the LLMs, the next generation LLMs will always outperform the narrow AI performance. So we should be very thoughtful about putting too much trust in a narrow model. It doesn't mean that narrow models don't have applications, but what it really says is us understanding and perfecting how we build these generative AI models, these new LLMs, will be transformative and will give us huge competitive advantage, whether it's in industry or whether it is in military applications, in government, or any other decision process we make. Because what generative AI arms us with is time advantage. It is able to ingest large amounts of information that fundamentally does not require a complete model of the world to lead you to solution sets that you did not think was possible. And for all you researchers out there, the Monte Carlo approach of search tree searching is fundamental to why these systems work. Now, we've grown up on the stack. Anybody who's worked in the geospatial world has always embraced the stack. And this is the stack we all are familiar with in the geospatial reality in which we do many of our works. And we always start with this idea of base knowledge, right? A base map, a base layer. Well, the challenge with that mindset is that there is a base. There is something that's immutable, that does not change. There is nothing in the world that does not change. Everything, including our bodies, are affected by time. So if we build a stack on a base model, we are fundamentally already obsolete on whatever that model comes back and tells us about. The second point about the stack, it is built about our human understanding of the world. So we build layers that humans can understand. The sensors who are picking up energy from either an aircraft, outer space, or from your phone, right, has to go through a bunch of transforms so our idiot brains, through our Mark I eyeballs, can understand what's going on. The machine, as we all know in AI, doesn't need to have that transform. In fact, every time we do one of these transforms, we lose information, we lose precision, because you're trying to get it to human understanding. It is also built on sensors. So each part of our stack, many of our layers are based on the sensor that's collecting the information. It's the SAR collection platform. It is the multispectral collection platform. It's the EO platform. It's going out and taking text data and putting a geospatial stamp and transform that into each one of these layers. What does generative AI do? It takes that stack and munges it all together into stew that potentially can give you information. It potentially can create new layers, a new way of presenting information that gives you a competitive advantage. It can take SAR, it can take EO, and create a completely different synthetic layer that video gamers understand, right? How many people here own a Tesla or an EV? Raise your hand. Okay, for those people, you know when you're driving around, you're looking at the screen when you should be looking out the window, but you're looking at the screen, right? What do you see? As you're driving along, you see this 3D toy-like car on the screen. You see a dummy-like individual who represents a person walking across the street. You're seeing a symbolic representation of the world in which the sensors are seeing and is using for interpretation, because it needs to understand not to hit that dummy because that dummy is a real person, right? Not to hit that car, not to miss that turn or drive into that tree. It simplifies the information so that algorithms can make faster decisions. It also simplifies the information so humans are not data overloaded, right? So this idea of all we need to do is add more pixels to the imagery for us to have a better understanding of the world. That may be true in the analytical framework if time didn't matter and your decision process requirements were near to infinite. And this was the key point. We have a whole generation growing up on real-time information, right? We all grew up with the Encyclopedia Britannica and the World Book Encyclopedias, right? Our kids look at that, and my son kind of went to my mother's home and pulled out, like, what are these things? What's in an encyclopedia? What's an atlas, right? Because that's the old way in which we need the information. What we need today is what piece of information that I need about this XYZ point in time that I need to make a decision on now. Currency. Whoever can make that faster decision wins all. For all those who are in trading of stocks, we all know that a handful of microseconds gives you trade advantage that yields hundreds of millions of dollars in returns on investment if I'm a stock trader, because I can get that information slightly faster than the other person. I can make that execution on that trade faster than the other person. I win the trade. If I am a warfighter sitting in the F-35, if I can reach out and touch somebody before they can reach out and touch me, I'm going to win the fight. In a world where information is hidden, it's camouflaged, it's misdirected, in a world where information is imperfect and truth is sketchy, having that information and getting resolution on that information, and I'm not talking about pixels, resolution as an information, leads me to faster decision making. Now, I'll just say this to all the warfighters in the room. We're betting on things like stealth and hypersonics. What does that really mean? It means about compressing the decision loop time for our adversaries so that they are unable to respond from the moment they get resolution. In other words, we have a saying, you're kind of waking up dead. You do not want to find your first understanding of the world is when the missile is striking your tail. The same thing is true when you're driving around. You don't need that information of where the gas station was 3 seconds when the gas station was behind you. You need to know when it's going to be ahead of you. And you need algorithms that predict what the potential futures are. For any of you who play hockey or play sports, right? You tell the quarterback to throw the ball to where the receiver is going. You hit the puck to where the forward is actually going to drive that puck into the net. It's not just about where we are at this moment, it's about where we're going to be in the context of what we're trying to get done. Real-time systems are going to be driven by next-generation hardware. Okay, so by 2028, we will all have glasses with information in our heads. Literally, we'll put using waveguides and next-generation compute, right? You won't walk around with these things that look like ski masks, as Apple hopes that case may be. But we will have that, right, in a pair of normal-looking glasses. We will have it directly in our headsets, right? So Siri is going to be predictive. Siri will know where you're going in the context of your daily life and give you recommendations. It will be your Radar O'Reilly. It will answer your question before you have the question. That's the future that we're heading to. So that kind of comes down to some areas of research which we need to talk about. There's a lot of things we don't have. Fundamentally, we do not have the data architecture and information infrastructure that organizes the world's data geospatially, that's in recall mode, that's able to recall that information nearly instantaneously and in context. Whoever builds that system not only will make billions of dollars, and please give me a call because I would really love to invest in you, but also fundamentally, we need to have that architecture, or we're going to need to drive our systems of the future, whether it's government systems, defense systems, or information systems. We need to understand also the difference between conjecture and truth that comes out of these algorithms. So we need a lot more research on information validation. Again, it's sort of like my daughter. I need to have a filter on what she says. I haven't figured that out yet. But if we can invest in that filter to say, this is speculation, hallucinating, this is truth, here's the truth fact pattern behind it, even though the algorithm didn't use that pattern to come up with that answer, we need a different validation model. We need digital twins that actually model the world so that we can take these scenarios, run them 1 million times, and optimize them in the real world context and helping us in decision support loops. And we need to understand the human-machine interface, because the danger here is we create another Tesla. And I know this, I live in San Francisco, everybody has a Tesla. Everybody sold their Priuses, they all have Teslas now. Nobody has a BMW. If you have a BMW, you're old, right? Everybody has a Tesla. And I watched, there's a freeway called 280 in San Francisco that goes from Silicon Valley to San Francisco. All the drivers of these Teslas not paying attention as they're in autopilot mode until it works 99.99% of the time until it doesn't work. And as you're going 65 miles an hour into a barrier that's made of concrete, you do not have enough time between when the machine kind of goes, I don't know what the hell is going on, to when you're paying attention, you're already dead. So that human UI interface of knowing what to trust, when to trust, and when to ask it more questions needs to be understood, and it's the soft sciences that need to understand that. The soft sciences of how we process data in our heads based on when the machine is putting that information in our heads. And the last part that's really, really important, and that is the ethical uses of these technologies. If we're going to rely on these machines to help us make decisions, in some cases make the decisions for us, because there's not enough time for us to humanly respond, then we need some ways to think about, it's not just about guardrails, right? How do we embed our ethical values into these algorithms? That's the difference between us and our peer competitors. It's the thing that makes us Americans versus somebody else. We hold these truths to be self-evident. It needs to be built into our algorithms. And if we're successful, we will transform the world. And the world will be running on our technologies, not somebody else's that may not have that same ethical framework, that same sense of truth, the understanding of reliance that we will all draw our decision and information from. So with that, open to Q&A.
I have the pleasure of conducting the Q&A with you, as I said to you earlier. Well, what you said just blows my mind. You know, when I was a journalist, we always had this name called Joe Q Public, that you have to talk to Joe Q Public. And you touched on it a little bit but I'm Joe Q Public, so how is this going to really change my life and when?
You know, I think what's important is our understanding of not just how much we rely on these technologies today. I mean, if you have an iPhone versus Android, I think Android has the same app. It comes back and tells you how much screen time you spend on your device, right? It was supposed to help parents, quite frankly, control their teenagers, but it turns out the parents are even more abusers than their kids, right? And so if you're kind of, when I was growing up, it used to be the boob tube, right?
Yeah.
How many hours do you spend in front of the TV? Where the average person back in the old days would spend somewhere between 4 and 8 hours in front of the television set. Okay, we haven't progressed very much. We're just changing the screen into what
the smaller screen?
Into the smaller screen. The difference is we didn't rely on the boob tube to make real-time decisions.
Right.
We're relying on our version of the boob tube to make real-time decisions. It's not just decisions for myself. When I hook up to the social graph, I'm influencing everybody in my graph, right? And so the consequences of mistakes, misinformation, disinformations, or us just thinking that we're agreeing with something that goes through an algorithm that then changes how everybody else gets that information.
That's why I don't use ChatGPT that much. It scares me.
I mean, if you're using Amazon, regardless, you're informing an AI algorithm, right?
That's true.
So now, fast forward into the future, when that information requires you to actually do one of this, turn on your phone and press this, and then when it's here all the time, where all the sensors are integrated between our physical sensors, our environmental sensors, and the world's data, that's game-changing. And so people asking what's that going to be like, I just go to science fiction. You know, it's the computer talking to James T. Kirk. It's R2-D2 talking to Luke Skywalker. That isn't 100 years away. That's 5 years away. And we better be prepared for it. And what we're trying to do you hear a lot of us technologists talking about this. You know, you have the head of Google, the Microsoft, right? They're all going on, and kind of quietly, Elon Musk whispering, you know, we're building this stuff, it's going to be really, really great, but, you know, we're a little bit scared too. That's because look, we live, as I was saying earlier at breakfast, we're living our 1984 moment right now. I mean, you know, we introduced the Apple Macintosh in 1984, and we built 1984, right? A lot of the world's problems are driven by these technologies that we thought was going to be, you know, helpful for democracy. And it turns out that in many cases it's not.
So my question is, should I be happy about this? Concerned? How should I react to all of this?
You should be both, right? Well, look, it's an exciting new world. The potential for the ability to help educate an individual regardless of where he or she lives, regardless of their economic status, that we can have machine algorithms actually tune information so we can learn faster, we can make better decisions, we can be better advocates for democracy is extremely powerful. The ability to put a doctor in your pocket. Extremely powerful, right? But we have to build these systems knowing that there are consequences on how we build these systems, what information we draw from, and how those answers are shaped, right? There is no information. We just provide the information. We don't, that's all we do. That world will not exist in the future.
Because
everything will be
as you said, it's the validation and the ethics of it.
Exactly right.
We have a question here. It was mentioned that Siri will be in our glasses and earbuds, essentially directing our lives. What do you think the effect will be on human cognition? We have already forgotten how to memorize phone numbers. I'm one of those. My husband can't navigate STL, St. Louis, without navigation anymore. Where is the line?
Okay, that's the downside, but here's the upside. The upside is I don't need to be an expert to do things that were not possible. I have a higher order functions. Now, for anybody who have children, this thing about 30 years ago, could we imagine our children building robots, programming them? Every kid, we got Lego Mindstorm. So our ability to use higher order cognitive skills like design and creativity gets unlocked because the keepers of information, right, the folks who you had to go to ask for permission to create something, you don't need them anymore. And so in some weird way, the artisan class could be a renewal for mankind because the artists will be back. There's a reason why design schools are over-enrolled throughout the country, right? It's higher order thinking, right? From a strategic level, what's the difference between the F-35 and a Su-35, other than one is made in Russia and one is made in the US? The difference is the pilot isn't just flying the aircraft. The pilot is orchestrating the battle with the screens that are in front of her and the information that's projected right into the helmet as she's looking right through her aircraft. Our ability to process information faster than our adversary means our adversaries are sitting ducks, right? Information wins. Information at speed is an advantage. It's our F-pole advantage. And information in context allows us to use our one thing that we have over the machine. And that's our conscious and our ethical understanding of the world around us that makes us human. Team with the machine gives us superior capability.
We'll end it on that note, on that high note. Thank you so much, Gilman Louie, for being here. We appreciate it. A round of applause. So now it's time for a 30-minute